A skydiver drops from rest from a hot air balloon and falls vertically under gravity for 5 seconds before his parachute opens. After the parachute has opened, his speed of descent reduces with uniform retardation for a further 10 seconds until his speed is 4 meters per second. He then continues to travel at a constant speed of 4 meters per second until he reaches the ground 2 minutes after he left the hot air balloon. Calculate the speed of the skydiver just before his parachute opens. Draw a sketch of the velocity time graph for the skydiver's descent. Determine the height of the skydiver above the ground when he drops from the hot air balloon. Okay then, let's have a look at this. Then I've got the information in summary form here. The chute opens initially, jumps from the hot air balloon. For 5 seconds he accelerates to here, and then he opens his chute here, so we don't know the velocity here. Then for 10 seconds he experiences a retardation until his speed comes down to 4 meters per second. And from then on he continues to go in a constant velocity of 4 and hits the ground 2 minutes later after leaving the hot air balloon. So we need V. We're assuming no air resistance here, so let's have a look at that then. Calculate the speed as the chute opens would be the velocity here. So this velocity equals U plus AT. Apply this formula then, because we know the time, we know the initial velocity, and we know the acceleration is the acceleration due to gravity, assuming there's no air resistance. So V is equal to then, U is 0, plus the acceleration is g, times the time is 5. So velocity is 5 g. 5 times 9.8 is 49 meters per second. We can tap that in the calculator if we need to. So B, draw a velocity time graph. So I'm going to do a quick sketch of that then. Here. So let's just do it here and along here. Now his fastest velocity was 49, wasn't it? So I'm going to mark off 49 here as the top value, or 50 rather, as the top value. So we can scale down. I'll just do it loosely in terms of this sketch. So we're going up in tens. The total time is 2 minutes or 120 seconds. So there's 120. Just there. 60. So this would be 30. And then 90. So it's 10 and 20, 40 and 50, 70 and 80, 100 and 110. Okay, so this is the time. This is the velocity. Okay, so initially the velocity is 0 at time t equals 0. Then it accelerates to 49 after 5 seconds. So up here is there. And that's the, I'll draw a dashed line because it's easier for me to do a dashed line on the sketch with the pen, digital pen. So there's 49. And then he suffers a retardation then, doesn't he, for the next 10 seconds. So that's 5, 10, 10 seconds more is 15. This is 5, wasn't it? That was 10 and that was 20. So then he has a retardation and he goes down to 4. So there's the retardation then, down to here. And then from here on in, it's basically a straight line, because he carries on at 4 all the way through. So I'll draw a dashed line. As I say, it's hard to draw with a digital pen, but a straight line, so I'll draw it as a dashed line. So there's our velocity time graph then. Okay, so this is the diver. So we've done that, that's part B. So part C, find the overall height. Well, the height, the distance travelled, would be the area under the curve, wouldn't it, here? So what have we got then? We've got this. So we've got basically this triangle here. We've got this rectangle, and we've got this triangle here and this triangle here. So this area, we'll call it area 1, is equal to half base, 5/2, times the height, which is 49, wasn't it? So there's area 1. Area 2 here. Well, again, it's half base. This was to... oh, it goes to 10... yeah, a further 10 seconds, so it needs to come out to here, doesn't it? So I need to resketch that, because it's not quite right. Oops. Okay, so let's resketch that. It comes out to 15, because it's a further 10 seconds, not a total. There we are. So here's the point here. So we've got this area here. So that was area 1 then. This is area 2. Half base, which is 10, times the height of this would be 49, take away this height here, which is 4, so it's 45. So that's area 2. And then area 3 is equal to this area here, from 120 through to 5 is 115. Half base then, half of 115, times the height, which is 10, which is 4 rather, isn't it? If we remember, this height is 4. There we go. So the total height then, the overall height, C. So the answer then, the overall height will be the area under the curve, which is this, 5 times 49/2 plus 10/2 is 5, 5 times 45, plus 4/2 is 2, 2 times 115. So let's tap that in the calculator then. 2 times 115 is 230. 545 plus 5 times 45 plus, just move the calculator to one side, and we've got 5 times 49/2. 5 times 49 divided by 2 equals 577.5 meters. 577.5 meters. That's the overall height. Just one slight change here. The area of this triangle is half base times height. The area of that triangle is half base times height. But this is a rectangle, not a triangle. So it's just length times breadth, isn't it? Or base times height. So this half doesn't need to be there. So basically it's another 230 on top. So it's 230 more. So if we can just add that in then. So this will be 4. So you're adding on another 230 basically. So 230 more would be 807.5. Just adding 230 more on the calculation. So it's 807.5 meters is the total distance from the hot air balloon to the ground.